the feedback for this. Okay. I need to turn. All right. Okay. Now, this is the state before collision. Okay. So, uh, we can say that whatever the total momentum of these two objects altogether is the initial state before the collision, right? So let's sum that up, right? Let's say whatever the motion this object has, let's say if this were moving, then it would be a different story, but this positive sign would be the same, right? For addition of these two momenta. Why? Because they have this capacity due to their motion, whether they have the value of it, right, if they have a magnitude or not, compared to what they are going to have after the collision, right? So we can say that the initial state or sum of momenta, right? I'm using the word momenta because this is the plural word, right? Momentum is singular. Okay, sum of momenta, right? That would be PAI plus PBI, right? The initial momenta, and that is going to be the sum of these ones, right? MAUA plus MBUB. Okay. Now this is the initial state. Now let's say what happens when it does come and collide with it, right? Now there's a bang, they collided, and what we are going to observe is that whether the B is going to move, whether the A is going to bounce back off, right? Or they're going to start moving together, or they're going to start moving forward, but in may be different. Now so we have several possibilities over here, right? If I start listing, right, let's just say A and B, right? I'm just going to use arrows to represent what could happen, right? Currently A is moving, right, state 1, and B is stationary. I'm just going to use the vertical line as stationary, right? So A comes, it collides. I mean, the end result is going to be maybe that A is going to just come and bounce back off, right? That's case number 1, right? Case number 2, A comes, right? The B is stationary, but the B is now moving and A is moving slower, right? You can see the length of the arrows are, they're different, right? That's the magnitude of the speed that is there for each object after collision. Now these are after collision, right? I'm just speculating, right? Is anyone not able to understand so far what I'm trying to do? Girls and boys? Anyone? Who's any questions? Can you guys hear me? Okay. No questions. All right. Okay. The third case could be, right, that A comes, hits B, and bounces back off. Also, the B starts moving forward but a little slower, right? That could be the case, right? And there are several other possibilities that are there. Now this, if we started to think, that is going to use a lot of time. So what we use is introduce a concept as law of conservation of momentum, right? And what this means, that whatever happened before, whatever this mass and the speed sum before the collision is going to be equal to whatever is going to happen after the collision, right? So we can say that the initial state of momenta, right, whatever the sum, how many, no matter how many objects are there, right? If they're moving, let's say if you talk about a billiard game, right, where there's so many, colored, balls over there, you use the cue ball to hit them. They move about, they collide with one another, and they're exchanging energies, right? At that point, so the initial state and the final state should match, right? In terms of the total momenta that is involved in this whole case, right? So we can say that the final state should be equal to the initial, right? Now, to represent this, I'm going to draw that after the collision, right? One case that over here, this is the B, right? The A hit it, right? After the collision, A is getting a little smaller, let's say 1 meter per second, right? That's the case what happened to it after the collision, and the B is actually moving at a certain speed. Now we want to know the final speed of B, right? We do know their masses. This is 2 kilograms, right? And this is 5 kilograms. Okay, and this is the speed after the collision, right? Let's say after the collision, A slowed down a little bit, but B started moving, right? It's moving forward. Whether they're moving at the same speed, whether B is moving faster or slower, that we can easily calculate using this idea, right? So I can say that the change in momentum before the collision, right, I, the initial state, should be equal to the change in momentum after the collision, right? Now I'm using this symbol delta, right? I've told you about this. This means change, right? When we were doing speed, right? The topic of speed. I introduced this symbol over there, right? Change. Now your book is using the whole complete statement, change of momenta. I just use a symbolic language for this, okay? Now this is going to be P of I for the object A, the initial state, and the P of I B for the final, right? Should be equal to P F of A, right? And P F of B, right? For the object A, for the object B, the final momenta, right? And the initial momenta for object A and B, right? So M A U A plus M B U B should be equal to M A V A plus M B V B, right? Now this is the whole equation that you're going to get. Now this does look a little scary to look at, right, at first, but once you understand that the change of momentum is equal, and you comprehend the concept of the change of momentum across objects while they're colliding, whether moving, where they change directions, right? So it's a very fascinating idea where you can easily calculate what is going to happen to the other object after the collision, right? Even if you don't know the outcome on your own, right? So this is the initial case that we're working on, right? I'm just going to show you the first diagram that we worked on. A was coming, it was going to collide with B. B is sitting still, it's stationary. I want to know what happened to B once this moving object has come and hit the object, B. Okay, so in that case we're using this data, right? So for the initial, right, we know, right, I'm going to now list the data for this, right, for solving this case. MA, the mass of object A, is 2 kilograms, right? The mass of B object is stated to be 5 kilograms, okay? The initial speed of A is 5 meters per second. The initial speed of B is 0 meter per second because it is at rest, okay? And the final speed, which I just drew on the diagram, right here, is 1 meter per second, okay? So 1 meter per second. And we want to know what happened to B, right? What will happen to B, right? For this, we're going to use this data in this equation that we have, right? This is the data which is usually available in the question, either in the form of statements like this one, right? I did not give the value directly, right? Maybe the question is stating that the object was sitting at rest after the collision, this happened, right? So it would not just give you the value. So you can comprehend such values from the context of the question, right? You should be able to read the questions thoroughly, right? And that is the very reason I've asked you guys to follow up on the past papers, right? So by the way, for the fun fact, for the class, right, I've got something for you people, because I know this was going to be your first digital class. So I prepared some fun for you, right? This quiz one, you have to solve this, right? I'll give you a clocking time for this, right, at the end of the class, and then you'll have to finish it within the given amount of time. If you're not, it's just going to mark you up to the point that you have covered, right? Or maybe it's not going to get submitted if you get late for it, right? So if you don't know the answer, just move quickly. I'm just going to give you 10 minutes to solve this as much as you can, right? All right? Okay. That'll be it for the end of the class. So, okay. So, for this case again, right, we need to find this. And to get this, we just need to put in all these values. This, I'm going to call it as 0 because we do know that the initial speed of B was 0. So if I multiply this with the mass of B, it's going to end up being 0, right? This term would be 0. So I'm just going to use these values. For MA 2 multiplied by the initial UA, which is 5, right, plus 0, right, the initial of B, this is B and this is A, right? And for this one again, it is going to be 2 into 1, right, whatever the speed was left after the collision, okay, plus the mass of B, which is 5, multiplied by VB, which we don't know, so we need to find this, right? Again, we're talking about A and B objects, right? So this is going to be 10 is equal to 2 plus 5 VB, right? And I can resolve this algebraically, right? 10 minus 2 and 5 VB, that is going to be 8 divided by 5 being equal to VB, right? And if you can resolve this, you can get the speed at which VB is moving, right? And for us, that is going to be a value of 1.6, right? So 1.6 meters, 1.6 meters per second. That's your value, right? This was the speed at which the object B would be moving once the collision has taken place. Okay? Are you guys clear so far? Anyone having any troubles? Okay. Seemingly good. All right. All right. Okay. Okay. I'm just going to minimize this, right? I'm going to get to this. You guys can minimize your current screen, right, on which this video is being played, right? So far, I mean, this we have covered the topic. So you just go to this quiz. Let's get to this, right? Immediately open this quiz on your class, right, where your main channels are. On click your team, go to IGCSE. You're already here, by the way, right? So just on this, you will find this tab, IGCSE Physics Quiz 1. Please start looking at it, right? Start solving this. I can open it up on my screen for you guys to think, but again, you have to give the input on the forms, so you have to use this, right? You'll be using your login. It might just ask you to log in again, but it shouldn't because you're already logged into Teams, right? If you're using the official ID, you'll be able to fill this up. Okay, have a quick look. Okay. Can you guys see the format you're in? Anyone having any troubles? Boys and girls? Yes, Aris? You are not in the team. Okay, let me just change the setting for that as well, right? Uh, on the quiz. I'll change it from there. No worries. Just give me a moment. Yeah, it's not loading. I'm just having the same issue as of now. By the way, I checked it like 3 times since yesterday. I'm still opening this. It's opening at the browser, but not on the Teams app. I don't know why. Okay, it's supposed to actually. Otherwise, I'm just going to share the link over here. Let me see if anyone can respond. Anyone can respond. Okay, I'm just going to keep it to open. I need to change that setting. Then I'll share it directly from here. Okay. All right. Oh, oh. It's it's not opening at my end either. Okay, we can get back to the board then. No worries. I mean, it's been a long time today. I mean, I don't know why it's working. Okay, I'm coming back to the board. This is the form. We can do it from here. Are you guys able to see this on the screen? Okay, perfect. The problem is all the options are visible over here, right? Let me just turn them off because this is from where I'm sharing it, right? It's going from the SharePoint. Multiple apps are working together while you're working with Teams, right? So I don't know. Even at my end, as you can see, I'm trying to open this up, but somehow it's not loading. I've checked it actually, right? Before you know, finalizing my whole class, right? I made the quiz over here. Oh, it's here. Okay, give it a try again, please. It's working for me now, as you can see on my screen. You guys can read it from here, by the way, as well, if you're not able to access, because the answer is not here. That's good. Let's go with this. Can you guys read this? It's a bit blurry. Hi. Um, Anyone else having the blurry issue? None? Okay, let's leave it. Okay, you guys can access this. Maybe the Teams is like too overloaded immediately to, yeah? You can see it. That's what I said. Like, give it a little time, it would load up because your apps are not synced with it, right? My computer is, so as I said, I'm able to use this on multiple platforms, right? I was just opening this up on the browser. Here's the quiz for me, right? This is from where I'm sharing this. So these should work immediately, right? Because I have to make them timed. But I just removed the timing system for this one. It's an automated, response taking quiz that you have to solve. Please, rest of you, give it a try. Are you guys able to handle this? Haris, you unfortunately, my dear, would not be able to solve this because there are several restrictions by uh, the Teams profile that I have to use for school, right? This is the school given, and I have to conduct the classes uh, intentionally over here, right? You can say for compliance, right? In that case, I am not able to share the quiz with you. I can share this form directly with you as an independent, right? For later use as well. But you can just work with Archive for now, right? Note your answers on a piece of paper, and you can just send me over the picture as well if you want. By the way, are you guys enjoying this? Not so much. No worries, I've got something more fun coming for you, right? Let me just open that in the background while you guys work at it. Oh, I love taking digital classroom is fun, guys. Let me just show you. It's boring. I'm just gonna make it better if you're looking at the screen. By the way, you're filling the forms, right? I'm just opening up some simulations at the back. Let me see how we should collide objects. Collision lab, collision lab. Hmm. Ah, there we go. Okay. So you guys are filling the form? Akif is awfully sending hearts. Why? Why? Oh, those hearts are for me though. Yeah? How much have you covered, by the way? I'm not gonna give you whole day for this form, by the way. Be quick. I've got two sections. This is one is the MCQ, the other is the real one. Oh, I can't move forward. Yes. You. How could you have a question? This is my time to question. Yes. Okay. MCQ. I cannot move there because, my dear, I'll have to fill this up. Unfortunately, it's at your end. Let me see if on the form side. Okay. This one? Okay. So calculate the change in momentum of hammer. That's one thing you have to calculate. State the impulse in nail. calculate average force between the hammer and the nail. This is the case study that is for you, right? You have to calculate these three things. It's for 6 points. Each answer guarantees you 2 marks. Okay. So the figure 2.1 shows a hammer being used to drive a nail into a piece of wood. Hammer, nail, and the wood is drawn in the figure. The mass of the hammerhead is 0.15 kilograms. The speed of the hammerhead when it hits the nail is 8 meters per second. The time for which the hammerhead is in contact with the nail is 0.0015 seconds. The hammerhead stops after hitting the nail. Right? Now this is the case that is there. They have given you some of the data, but rest you have to work on your own and you have to calculate this change, right? Please don't mind the double A. My keyboard is doing this, prank on me. I press it down once, it just writes two A's for no reason. Maybe too much gaming lately. Okay, yes. Are you able to understand Ishtiaq? Any queries now? Don't expect me to give you the method for this. Okay. I hope it works. Okay. Yes, Abdullah Sahib, you've got your hands up. Abdullah, hello. Be quick. I have to use the collision lab. Be quick. Come on, come on, come on. I'm gonna give you just 4 more minutes. Okay? Be done with this quiz. 4 minutes. There's 31 now. 32. 3 minutes left. Be quick. I need to use a collision lab and we're going to discuss another topic over there. Hmm. Sybil, are you doing this? Aisha, my dear, I haven't heard your voice so far. Are you doing this at the back? You're not Aisha. Okay, Aisha. Aisha Ismail, my dear. Okay, good. You guys, if you don't have noise at the back, like unlike my house, which is like one construction site and a vacuum going there as well. If you have like silent background at the back, please keep your mic open. I don't mind that. You guys are educated people. Yes, Abdullah. I'm not able to hear you though. Uh, Let me just see if I can let the chat go on. Because if I let the chat on, you guys just keep on sending those things. I don't want you guys to waste your time on the chatting. That's why I blocked it. Yes. Yep. No, no, no values. No, no, not here. It is a graded one. You'll get receive your grade automatically over there, by the way. I can send you. I've received one response, by the way, so far. Oh, who's done it? Let me see. Okay. Average score of 3. Well done. What have you done? Who sent this so far? I'm not gonna open it on my screen though. I mean I'm just gonna let the name hidden out. That's why I'm just asking in name. Okay, because that way the whole result would be in front of everyone, right? Okay. I'm just gonna check back later. Okay. So 3 marks. Okay, good. Others, are you guys done? Come on, quickly, last minute. I will close the form from there, by the way. So be quick, submit, because I will stop taking responses for this. End time, let me put in. Then don't blame me if you're not able to submit, okay? Let's make it 10, 48, 38. Okay. Now I'm just gonna move my screen from here, right? And I'm gonna start working with the collision lab, because if you haven't submitted, that's like you're taking too much time on this. Like, it was pretty easy. So let's move on to the collision lab. Meanwhile, you guys who are having, I mean, slow internet, I've given you 3 minutes extra for submission, not for solving. Okay, submission only, I'm saying. So yes, 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 Ishtiyaq. Okay, done. I mean, I'll get to see later. I mean, that's the fun part of it. I've received 5 responses so far, right? 5 of you have submitted. So I'm gonna check back later, because I can get all details, who did it, what were the correct questions and answers. By the way, the long question is not going to mark automatically, because I have to check it manually, right? I'll check it manually and assign the grades individually. Then you'll be able to get the complete marks for it. Okay. Now I'm gonna go into this, right, collision lab, and this is a linear collision lab, right, in which where we're talking about motion of objects in one dimension, right? So initially both of them are at rest. You can see the range, right, which is there, the time, momenta diagram. This will tell you where is the net momentum, right? Since the overall mass for B is greater, right, if they're moving, these are the masses, right? I can increase the size over here, right, or I can reduce the size. Let's say if I've got a very big one, a very small one, with more data, right? These are the positioning if you want to use, right? Because we're talking in x-axis only, so I'm going to reduce the speed as well, right? But for now, I'm just going to see where the momentum is. I'm going to remove the speed. Okay, let's just go with the speed only, right? The values, right? These are the values which are there for the mass and this. And remember, this P over here is representing momenta, right? So I'm going to play this, and you're going to see what is going to happen, right? Oh, they're stuck. Oh God. So it just pushed it back. It's gonna make it faster. You see, it is now. It's going to happen again. And this is the fun part, right? You can just see how it pushes back. Now this is what we call as an elastic collision, right? Elastic collision means where there is no loss of energy. These are perfectly elastic collisions. Particles or the objects are colliding without any losses of energy. So they simply change their directions or motion, and while their masses remain constant. Now let's see what happens when I'm going to reduce this elastic behavior, right? I'm going to reduce the elasticity to 80%, right? So 20% on each collision, 20% energy is lost. As you can see, the speeds are changing, right, consistently. Although these are supposed to be constant speeds after and before the collision, right? But with each collision, you see the value is dropping for A. After the B is going to collide, it's going to slow down. As now you can see, eventually they will come to a simple halt, right? Now what I do is that I'm going to now increase the velocity, right? Let's say by 9, right? 3 to 3. Okay, that's giving me a range, and that I'm also gonna put it 3. So I'm just gonna start this off. Now I just started them off at a very high speed, but you see how much, the more the collisions it had, the more the energy it lost, right? I'm going to restart this again, right? Now in the opposite direction, right? So I'm just going to use -3 of a value over here, right? Okay. One is going this way, the other is going this way, right? And I'm going to keep them elastic, right? Just to show you how crazy this gets in terms of vibrations, right? This is what you also call as vibration, right? So these objects are vibrating because they're fixed in a certain axis, right? We are not letting them move in multiple directions. Now this was just a say one-dimensional analysis, right? Now I'm going to go back and I'm going to increase the parameters for this one, right? Now I'm going to go into two-dimensional objects, right? Now one object is moving this way. I can change its speed or vector. Let's say A is going this fast and B is going very slow, right? And these are elastic collisions, and I just let them around. So you can see how the objects are going to collide, right? I'm going to turn on their paths as well, right? It will trace where they were going and where they're coming from, so you can easily see what is happening to the object's direction, right? So this is how exactly the gas particles are, by the way, colliding, right? This is what you will study as the particle nature of matter, right? If you guys have been studying science previously, checkpoint science, you guys know I've discussed this topic very frequently, right? The particle behavior, I keep on referring to this. Particle theory and the collision theory, right? If you guys remember, even in the topics of chemistry, I've discussed this, right? So this is the main idea behind the momentum, and you can see the vector sum as well, right? If you remember, we were doing vector summations, right? So you can see how the vectors are being summed up with the head to tail rule, with the black one being the resultant vector, right? Let me just slow it down so that you can see the change in vectoral diagram, right? Are you guys with me on this? Okay. Still boring? No? Okay. Now, see, this is what you guys are supposed to be doing on your paper. This is a scale diagram, by the way. And this scale, this small block you see, represents zero point 0.5 meters in distance, right? This is the scale. So if you were just looking at this in the idea, like it's like for little kids or whatever, like so trying to do some impression. So if you look at the numbers, this is actually very, very complicated stuff that is going around, right? So you can get more data. You can see now the two-dimensional velocities and the net momenta in the x and the y. So this is giving you data which is applicable to cases up to a level of A levels, right? So this is not just a simple fun tool to play with. It's a very, very amazing calculator where you can simulate any kind of uh, you know uh, articles you want to, like you can add more objects, right? You can go crazy with that. So see what happens. Now as you can see, it's going a little laggy, right? This simulation, but that's how much I think their servers can support on a website. But it's an amazing website to go through, right? I've been telling you guys since grade 8 as well, right? That use FET simulation, it is amazing from basic beginning level to advanced data. You can get everything from this, right? Even the energy, we've been doing motion, right? So spring mass systems we will be studying, so we will refer to this. That's why I've been telling you that your digital there, the vector addition, if you want to do the scale diagrams, right? So you have these tools with you to work on, so please explore them for your academic requirements, not just because I give you an RA or something, just because you want to learn something, okay? So you can put some vectors and see what the sum can be, right? I've taken vector A, I'm just gonna put vector B over there. This is the head to tail rule, and see what vector summation looks like, okay? Just giving you a little brief of what you can do with this, okay? Now if I take the sum of it, so this is the net vector that is supposed to be there, right? I don't know why I placed it there, but it was supposed to be here. Okay, this is the net sum of the vectors, this dark blue one. Okay, so you can practice a lot on this tool, right? We'll explore this more for doing cases tomorrow, right? And we'll see if you guys can crack the case for a collision case that I'm going to make for you, right? Uh, Now, have you guys submitted? Let's sum up the lesson. Have you guys submitted the quiz? All of you. Coming back to you guys. Everyone's done? Okay, I see very little number of candidates with me, and we've got only 7 kids with us, right? So let me just mark your attendance over here as well, right? Your let's record your attendance. Okay, meeting info. All right. Okay. You have your next class. For me, this is sign off. Your notebook, by the way, this one is not attached on your Teams. Yes, yes, Abdullah Ahmad. Yes. Mm-hmm. Head to tail rule. Simple. Head of the first goes to the tail of the last. You keep on adding vectors like that. जिस तरह अभी मैंने यहाँ उल्टे सीधे डायरेक्शन में लगा दिए थे दो तीन. Let me just give you a little. We have rest of you. If you wanna move towards the next class, you're free to go. I'm just gonna show Abdullah this vector addition. Just open करो यार इसको enjoy करो. This is a very fun tool to play with, right? This is where others are working, right? So ये मैंने उस दिन भी बताया था क्लासरूम में कि इसको खोलो, इसको try करो, see where these vectors go, right? Now this is the head to tail rule. Vector A, first vector, second vector and third vector, right? अच्छा ये ऐड किस तरह हो रहे हैं कि जब भी मैं एक I move the head of the first and you have to make sure that the tail is joined to the head of the previous one, right? एक दूसरे के सीक्वेंस में लगने चाहिए. Generically तो अगर मैं इसको ज़रा simpler एग्जाम्पल में कन्वर्ट करूँ तो लेट्स से दिस इज वेक्टर 1, दिस इज वेक्टर 2. मैं देखना चाह रहा हूँ कि एक बंदा गया है तो कितनी दूर गया है, राइट? आई वांट टू सी हिज नेट मूवमेंट फ्रॉम पॉइंट ए टू पॉइंट बी, राइट? वो इन डायरेक्शंस में गया है, इस पाथ पे गया है, तो ये तो उसका डिस्टेंस होगा ना. अगर हम इसका मैग्नीट्यूड लेते हैं तो दिस इज गोइंग टू बी द डिस्टेंस सम ऑफ दीज थ्री लेंथ्स ए बी एंड सी. अगर हम इनकी सिर्फ लेंथ्स को ऐड करें, ओके, एज यू कैन सी दिस 11.2, 11.4, 6.4, इनको सम अप करो तो ये आपका डिस्टेंस बनता है. लेकिन आई वांट टू नो कि उसके डिस्प्लेसमेंट कितनी है. डिस्प्लेसमेंट इज द नेट चेंज इन पोजीशन और वो होती है फाइनल से इनिशियल से फाइनल पोजीशन तक, राइट? एज ऑफ नाउ दिस इज चेंजिंग अ लिटिल बिट. मैं थोड़ा सा इसको और चेंज करता हूँ, राइट? आई एम गोना ट्राई एंड मूव दिस वन a little bit here, right? So you can see that the vector sum is changing as I'm changing the position. Are you clear on this, Abdullah? This is the head to tail rule, okay? Manually, we have done this in class, my dear. We have done like 6 questions on this. Beta, refer to Sibil's notebook on that. उसने किए हुए. She's been doing those on time. I think Kef and Haris has also done that. Yes, Sibyl, have you guys done this? ये किए आपने questions आपके पास noted हैं? ये प्लीज़ अपनी नोटबुक बेटा ये शेयर करना इन द क्लासरूम. अभी तो आपके असेसमेंट चल रहे हैं, दैट्स अनदर थिंग, बट दैट नीड्स टू बी डन. ओके, ऑलराइट. Abdullah, I think he has even done the past papers on this, right? Have you done this, Abdullah? You're working advanced, by the way. कहाँ तक पहुँचे हो आप? How much you have covered? And by the way, please move into your next class. Your teacher would kill me, right? Okay. If anyone has any queries, you can just stay online and rest. Who have no queries, please move to the next class. Okay. Your link would be shared in the team. Yes. Anyone having any issues? Yes, Ishtaq, you want to say something? Okay. Bye bye, Sabu. Yeah. Okay. Move to the next one then. Ishtaq. Bye bye. Yes, Abdullah. इसको एक्सप्लोर करो अब्दुल्ला थोड़ा सा, ठीक है? एंड देन गो थ्रू, आई मीन नियरली ऑल ऑफ देम यार. हमने ये बहुत सारी की हैं क्लास में. अनफॉर्चुनेटली मैं ये नहीं करा सकता, राइट? आई हैव डन द बोर्ड क्वेश्चंस विद द वेक्टर सम्स. वहाँ पे हमने डिस्टेंस और डिस्प्लेसमेंट की थी फर्स्ट, और सेकंड अभी हमने क्वाइट रिसेंटली अभी हमने किया था फोर्स का, राइट? लेकिन उसमें जो हमने किया था, इफ यू रिमेंबर, वो एफ साइन थीटा एफ कॉस थीटा वाला वर्जन किया था, ठीक है? दैट इज एग्जैक्टली व्हाट इज हैपनिंग इन दिस वेक्टर सिमुलेशन. ये जो डायग्राम्स आपके सामने बन रही हैं उसके बैक पे फार्मूला वही यूज हो रहा है, राइट? क्योंकि सिमुलेशन खुद से तो कुछ नहीं करती ना, राइट? यू नीड टू यू नो टू मेक एनी सिमुलेशन वर्क, यू हैव टू पुट इन फार्मूलाज. तो ये बैक पे वही फार्मूलाज यूज हो रहे हैं जो हम यूज कर रहे हैं, पैथागोरस थ्योरम जिसको हम कहते हैं, राइट? द सम ऑफ द टू वेक्टर्स, राइट, रिजल्टिंग इन अ रिजल्टेंट. अगर ये मैं वर्टिकल वेक्टर्स मतलब परपेंडिकुलर हमने सिर्फ किया था. आई टोल्ड यू कि आपके कोर्स में सिर्फ ये दो वाला इंक्लूडेड है, राइट? जिसमें आपके 90 डिग्रीज पे रहेंगे आपके वेक्टर्स, ठीक है? वो तो यहाँ पे तो आप जितना मर्जी कॉम्प्लेक्स घुमा लो ना, बिकॉज वो फार्मूला ऑटोमेटिकली पीछे इट्स वर्किंग एट द बैक. सो दिस इज व्हाट यू डू इन योर कोर्स, राइट? इसके हमने कुछ क्वेश्चंस मैंने बोर्ड पे लिखे थे, राइट? देव डन दोज क्वेश्चंस. ओके, प्लीज़ उनको ट्रेस करना, नहीं तो पास पेपर में से उठा लो यार. वो बंडल आपका ही है, आप नहीं करना सॉल्व बच्चे. सो ओपन दैट पास पेपर बंडल, सी इफ यू गेट ट्रबल इन एनी क्वेश्चन, राइट? देन आई कैन हेल्प यू आउट ऑन दैट. ऑलराइट? ओके, टेक केयर, बाय बाय.